Assalamu alaikum. In this video, we are going to cover a topic named Bairstow method. This is another numerical method. Just like the numerical methods that we have learned so far, uh, this method also tries to look at roots of any given function. But the catch here is that Bairstow method works on the function if the function is given to us in the form of a polynomial. And one of the key advantages of Bairstow method is that it can not only locate real roots, it also works just as fine in locating complex roots as well. As as I have said, Bairstow method works only when the function given to us is in the form of a polynomial. So before we dive deeper into the working methods of Bairstow method, we should learn a few basics about polynomial. If f of x given to us is a polynomial, that should be rearranged in this format also. And if the remainder is 0, we can then say that the function can be rearranged as this, and a is one of the root of the given function. Now let us look at it from an example. Let's say we have a function of x given to us, which is obviously a polynomial, and we have been told that 1 is one of the roots of this function. So according to the rearrangement policy, this function should be rearranged as this. Okay. Now let us look at it in the inverse order. If we can write a function in this manner, we can say that if we just solve this part of the function, that gives us one of the roots of the function. Okay. What Bairstow method tries here is that if any function is given to us, it will try to convert that function or rearrange that function into this format. If anyhow we can prove that the remainder is 0, then we can say that the f of x is actually this part, and then we can focus on only this part of the function. See, this is a quadratic function and this can be solved easily, and the solution here will give us two roots. Since this is a quadratic equation, the solution of this part can generate even complex roots also. So the idea here is that we will try to convert any given function to us in this format, and we have to make sure while converting or rearranging the function in this format, the remainder remains 0. Or in the other words, if any function is given to us, we will look to convert it like this. If we can convert it in this way, we are now left with two separate functions. One is qx, another one is x square minus ux minus v. And this x square minus ux minus v is then a quadratic equation, and that can be solved quite easily, and that will generate two separate roots. And after that, we have solved this part of the f of x, and we can then focus on the qx. So at that point, we can think qx to be another function of x, and then keep rearranging it into this format, and then we will have another qx at our hand, and then we can run the loop till we reach to a point where we have found out all the roots of the given polynomial. Here the highest order of the polynomial is 3. That means we will keep running the loop until we have found the 3 roots. To sum up the Bairstow method, we can say that any f of x should be rearranged in this format. Let it be any format of the function, we should be able to rearrange it in this way. but we will try to convert it in such a way so that the remainder remains 0 and we can convert our f of x into this format. After we have converted into this format, we can shift our focus into solving this part of the equation, which is a quadratic equation, and solution of this quadratic equation will generate two roots. Then we can say that from the given function we have solved up to this part. Now we can focus on qx and we can think qx to be another function of x and then apply the same thing to that function, and we will be again left with one part of the qx, and we can convert it into another function x, or we can keep solving the qx that we are left with. So in this way, Bairstow method works on the polynomial and it runs this loop to find out the number of roots it can generate. So that is the basic overview of Bairstow method.